In this lesson, we shall focus on the Mathematics Paper 1, Grade 11, June 2022 past exam. It was written out of 100 marks in 2 hours in the Gauteng province in the Republic of South Africa. And we proceed to solve the entire paper from the beginning to the end as follows. Question 1 said, for which values of x is this expression real? Right, so let us analyze this and look at what this is supposed to mean. Any quick answers from you students? What do you think? When is it real? For which values of x is this expression real? Okay, so this expression is real surely if because it's a square root, so we must make sure that it is real if everything under the square root is greater or equal to 0. First and foremost. Like so. It is real if everything is greater or equal to 0. Then it's real, like this. Because everything must be greater or equal to 0. It's real. But in this inequality, the couple of things we need to take note of. The denominator is already greater or equal to 0 because it's a perfect square. Now, for this to surely be always greater or equal to 0, we only require that the numerator be greater or equal to 0 because there's no square there and it can, by accident, become negative. If x is -4, -4 plus 3 is -1. Okay, if x is -4, -4 plus 1 is a -3. You square -3, you get a 9. Plus 9. So, yeah, the denominator is always exactly that way. Okay, these just spring out because of my other recording from the previous lesson. I just was running. Okay, right. So now look at that and note therefore that for this to be greater or equal to, only the numerator must be greater than 0 or equal to 0, meaning x must be greater or equal to -3. First things first. Next, we require that the denominator, if each time there's a rational expression, we require that the denominator be different from 0, meaning we require the denominator must not be 0. X plus 1 squared must not be 0. Please, the denominator must not be 0. So what is the meaning of this? The denominator not being equal to 0. It means that x is not -1. Okay, because if ever x equals -1 here, you have -1 plus 1, which is 0. So x must not be equal to -1. So this is the answer to the question. X must be greater or equal to 3. Simultaneously, x must be exactly not equal to -1. And this is the answer. Where's the question? Where's the question? No question. We move forward. Right, 1.2.1, solve for x given this expression. So we're given x plus 4. We're given x minus 1 is equal to 0. Okay, what do we do here? We need to solve for x. What are the answers to this? X equals -4 or x equals 1. Okay, just going to talk to you a little bit. Okay, basic stuff. So next question. So yeah, here we're to solve for x given this. So x is -4 or x is 1. Okay, so they're going to obviously give you something to get your skills shown on solving equations. Quadratics first. Correct to 2 decimal places, solve this one. So we have 3x squared minus 2x equals 14. Okay, so this is 3x squared minus 2x minus 14 equals 0. Meaning x is minus b plus or minus the square root of b squared minus 4ac out of 2a, which is minus 2 plus or minus the square root of -2 squared minus 4a minus 14. Okay, so here you have a minus 14, like so, and this is all over twice a, and a is 3. Like so. Okay, what then do we do out of this? We're able to make certain observations. And the observations are that these can be simplified because there's a 2, and there's a 2 that's going to come from here. This simplifies to 1 plus or minus the square root of 43. Maybe let me write a little bit more steps here. Let me write a little bit more steps. So what we then have is negative, negative, which is plus, plus or minus. You divide by 6. You have the square root of, this becomes 4 times 43 using a calculator. And therefore, this is 2 plus or minus the square root of 4, square root of 43, divided by 6, which is 2 plus or minus the square root of 4, it's 2 square root of 43 out of 6. Okay, divide through by 2, 1 plus or minus square root of 43. Okay, square root of 43 out of 3. Okay, now pay attention because this is extremely important. This is extremely important. So it is actually plus or minus the square root of 43, which means that for x is 1 plus the square root of 43. Okay, yeah, out of 3, or x equals 1 minus 43. Yeah, so we need per topic in-depth analysis, Tando, to build you up. That is what is missing. Right, so that you can get the 100% in the exam. So 1 plus square root of 43 out of 3 is 2,52. Or x, 1 minus square root of 43 is actually minus 1,85. Using calculator. Okay, to 2 decimal places, these become the answers to this. Right, so obviously, see, the examiner said correct to 2 decimal places. So yeah, you have 2 decimal places rounding off here. Okay, good. And each one of these is in 3 significant figures. Okay, I'm going to spend time speaking about what you call, in science and mathematics, they are what you call figures we refer to as significant. So 3 significant figures. 3 significant figures. Okay, yeah, each of these. Okay, yeah, but we're not there yet. Significant figures, we're going to get there. Next point. Okay, let's look at 1.2.3. Now, let's solve. This one is the K method. So the K method is a very exciting one. So you lad. Okay, so yeah, first things first, in the way we actually solve these equations, we need x squared minus 2x equals 18 minus 45 over x squared minus 2x. Okay, what do? You let k be x squared minus 2x, so that wherever there is x squared minus 2x, you put k. Okay, you just put k. Wherever there is x squared minus 2x, you put k. You put k equals 18 minus 45 over k. Right, so at this point, you have this. And when you get to this, what then do you do? You consider the LCD, you consider all the denominators, and we only have basically denominator k here, which means we shall have k by k equals 18 by k minus 45. Okay, yeah, minus 45 over k. Right, so you shall have exactly that part. So over k, then we have k here. Okay, we have k by k, which is exactly k squared, which is 18k minus 45, which is k squared minus 18k plus 45 equals 0. And then you have this. What are the factors of k squared? K and k. What are the factors of 45? That give minus 18. Those factors are exactly minus 15 together with minus 3, giving us k equals 15 or k equals 3. Right, so at this point, we're going to consider these in 2 different ways. So now we have k equals 15, but k is x squared minus 2x, so that we have x squared minus 2x is equal to k. Because these are k is 15, so you really can have x squared minus 2x equals 15. Right, you have x squared minus 2x minus 15 equals 0. x minus, okay, the factors of minus 15 that give minus 2 are actually minus 5 and 3. Minus 5 plus 3 equals 0, which means x is 5 for x is minus 3. Okay, x is 5 for x minus 3. Okay, pay attention to this and make sure you understand this. Okay, yeah, I need to engage you a little bit, but yeah, I know that it's basic stuff. Right, after having obtained this now, we proceed to look at the other case because there are two values of k. Right, so the other value of k is going to occur when k equals 3. And we have that k is this one. So k is x squared minus 2x, which means it's x squared minus 2x equals 3. And it is x squared minus 2x minus 3 equals 0, which means x minus 3, x plus 1 equals 0. And this means at this point, what you then have is that x equals, so this moves to this side here. So that means that x is 3 or x is actually a minus 1. X is then minus 1. So pay particular attention to this. Please let me know if you have a question, but I know this is very, very easy. Okay, what was the question here? The question was to solve for x. Okay, have we solved for x? Yes, we have. Okay, what are the values of x? There are 4 values of x. X is 5, or x is minus 3, or x is actually minus 3, or rather positive 3, or x is 1. Okay, minus 1. Right, so minus 3 or minus 1, 5 or minus 3. Okay, yeah. So we use what we call the K method. The K method to solve for x here by letting K be what is popular, x squared minus 2x. It was the most popular, and we made it K and we solved for x. The next point, it's 11.2.4. Right, so to solve this particular one here, it involves a radical. And to solve equations involving radicals, what we do is we square both sides of the equation. Okay, I'm revising paper 1 because that is what is coming for most people. Okay, right, so first then we have minus x minus 1. And to solve, okay, because it's a big square root that is like the umbrella of everything on the left-hand side of the equation. So what we do is we square both sides of the equation. So we have exactly 5 minus x square root. We square the left and we square the right so that we have 5 minus x. If you square minus x, you have x squared. You multiply this by that, multiply by 2. And minus x times minus 1 gives us plus x times 2, they give us 2x plus 1, x squared. Okay, collecting like terms, etc. You have 2x, and this x becomes plus x plus 1 minus 5 equals 0, giving us x squared plus 3x minus 4 equals 0. Okay, let us get these factors quickly. Factors of x squared are x and x. The factors of minus 4 that give 3 are plus 4 together with minus 1. And at this point, we're able to see that x is minus 4 or x is 1. Okay, I want to mention something in passing here, but something very pivotal in the way we do factorizations. If you have x squared plus 3x minus 4 equals 0, there are a couple of things that remain important for us. What are they? Right, first we multiply x squared with minus 4, and we get actually minus 4x squared. And if you multiply x squared with minus 4, we look for the factors of minus 4x squared, factors of minus 4x squared that give plus 3x. And those factors are as follows. Right, so those factors are precisely 4x together with minus x. Because 4x times minus x, they give us minus 4x squared. Yet, if you add these for the middle term, right, 4x minus x will give us 3x. And this, as a consequence, gives us x squared plus 4x minus 4, this equals 0. Pick out x and you have x plus 4. Pick out negative and you have x plus 4 equals 0, giving us x plus 4. X minus 1 equals 0. X is 1. Right. So, okay. Yeah, I was just showing a different way to factorize this. Okay, because here I just factorized straight away, but here I just used the breakdown. So we broke down the 3x to this. Okay, it's called breakdown, breaking a number down. We need to check our solutions always after squaring both sides. Always. Okay, but now you take the 1 and you put here. If you put 1 the original, you can see it minus 1 here. But if you put 1 here, it becomes 5 minus 1 is 4. Square root of 4 is 2 plus 1, which is actually exactly a 2 plus 1 is a 3. Okay, and 3 is not equal to minus 1. So yeah, so x is not that, but x is minus 4, because if you put minus 4 in the place of x here, you have minus times minus 4, giving you a 4. If you put minus 4 here, you have 5 minus into minus 4, which is the square root of 9. Square root of 9 is 3. 3 plus 1 is a 4. 4 equals 4. And this one is brilliant. So in other words, I mean, one can say 1 is not applicable as a solution there, or x is not equal to 1, to exclude the 1 there. Okay, next we do 1.2.5. In 1.2.5, look, we have exponentials. Let's spend time on this. We have 3 to the power 2x plus 1 minus 4 times 3 to the power x equals minus 1. Now, the couple of things that remain very important. And to deal with this, we need to always break down. Always break down. I tell students, I was dealing with grade 10s earlier on today. And I told the grade 10s, please break the things down. So you're going to have 3 to the power 2x times 3 to the power 1 minus 4 times 3 to the power x plus 1 equals 0. Upon careful examination, we're able to see therefore that this is 3 to the power x squared like this, and you can put a 3 in front, minus 4, you can put a 3 to the power x in parentheses, plus 1 equals 0. At this point, we actually use the k method, the k substitution. So we let k be 3 to the power x, right? And if we do that, it becomes exactly 3k squared. Wherever there is 3 to the power x, you put k, so that it becomes 3k squared minus 4k plus 1 equals 0. What do we do next? We do factorization. We can get back to the basics a little bit. We take the factors of 3. We take 3k squared, we multiply by 1, and that gives us 3k squared. If you multiply 3k squared by 1, we look for the factors of 3k squared. That will give us minus 4, and those factors are obvious. They are actually minus 3k together with minus k, because if you multiply minus 3k minus k, they give us 3k squared. Yet minus 3k minus k gives us minus 4k. We have 3k squared minus 3k minus k, right? Plus 1 equals 0. We have 3k, which is k minus 1 minus k minus 1 equals 0. Okay, we took out the highest common factor from the first two terms. And therefore, you have k minus 1, and you have 3k minus 1 equals 0, which means that k equals 1 or k equals 1/3. K equals 1 or k equals 1/3. Now, what do we do next? So which means, therefore, at this point, you have that k is 3 to the power x. Right, so if k equals 3 to the power x, you can just do it here. Right, k equals 3 to the power x. Right, so if k is 3 to the power x, I mean, we are having the 3 to the power x together with the substitutions. For instance, values of k equals 1. So which means therefore you would have the substitution there. Okay, so case 1. So you put 1 equals 3 to the power x. 3 to the power 0 is 3 to the power x. Okay, because 1 is 3 to the power 0. And therefore, if the bases are the same, both 3, you equate the exponents, meaning x equals 0. You equate the indices, in other words. Okay, but you also simultaneously have k equals 1/3. Right, we have k equals 3 to the power x, but k equals 1/3, which means that 1/3 equals 3 to the power x, which is 3 to the power minus x is 3 to the power x. But when the bases are the same, you equate the exponents, which means x is minus 1. Okay, so yeah, what are the answers to this question? There are two values of x to this question. What are they? They are namely the following values of x. We have x equals 0 together with x equals minus 1. There are two values of x to this particular problem. We have solved for x here step by step, and we are done. We proceed to solve the next problem as follows. Right, so we have the following here. Right, so at this point, we're looking at 1.2.6, and we are trying to solve for x given this. Yeah. Right, 1.2.6, we want to solve for x given this. Right, so we have the following. Right, we have x squared minus 3x is less equal to 0. I'm going to use the standard approach that is expected from you. And at this point, what we do is we always take out the highest common factor here because these are only x terms. Each of the terms consists of the factor x. So do that. Take out the highest common factor. And there are certain things we call critical values. Critical values. Critical values would be x equals 0, x is 3. Okay, so you have 0 together with 3. Right, now what we're dealing with the part where the quadratic itself is less or equal to 0. The minute somebody tells you the quadratic here is less or equal to 0, it means that if this is the x-axis, it is certainly, we're looking for where it's negative. So it is negative below and it is obviously positive above. At this point, if we're looking for less or equal to 0, it is equal to 0 here, and it is less than 0 in the middle here. And therefore, that means that x itself, it lies between 0 and 3. Right? So if x lies between 0 and 3, you have inclusion of the endpoints because this is less or equal to 0. And this is the solution to this particular problem here. We have solved part A, 1.2.6, part A, and we are done. Next problem. Right, in 1.2.6 part B, if f of x equals x squared minus right, so we continue. We continue. Right. Right. Okay, we'll continue the next one. The next one is question B. And question B is rather a very, very exciting question, and it's very, very straightforward. So yeah, we're gonna have the following attempt. We're gonna have the following attempt. Right. We're gonna have the following attempt. Yeah, we're trying the question there. Right. So yeah, at this point, right, we're gonna look at part B of this. Right, if f of x is this quadratic function, it is this parabola. It is this parabola. Write down the values of x for which the parabola translated. But you see, it is f of x here, but here x is replaced by x minus 3, which is actually a translation of the parabola by 3 units right, or 3 units to the right. Okay, if it's 3 units to the right, then we have the following. Now, the couple of things, obviously, that remain very, very key here for us to take into account. We actually need to first ascertain the fact that we need to deal with the fact that this one has already been solved. Okay, we dealt with the part where, so we know that f of x is equal to x squared minus 3x. We have already looked at the part where this one is less or equal to 0. And the solutions here that we got are these ones here. So the x between 0 and 3 inclusive. X between 0 and 3 inclusive. Now, let's look at what happens here. Okay, here we are having x replaced by x minus 3, which means we have x minus 3 squared minus 3x minus 3 is less or equal to 0. Right, so at this point, what is this? Well, it means that every x is replaced by x minus 3. And you remember the quadratic here? It was having 3, 0, 3 here. And we were dealing with the bottom part of it. Okay, but now if you then say that this is actually now translated 3 units, right? Or 3 units to the right. So you're going to take this one 3 units to the right. So if this is 3 here, right, if this is 3 here, then what you're going to have is 3 units to the right. Right, so it's going to be a 6 here, 3 units to the right. We're going to move 3 units again, 6. This was 0, so it's going to be like a 3. And then the new graph is going to be the green graph. So I'm going to sketch the green one. Green one, like so. Okay, so it's going to be cutting at 3 here. It's going to be cutting at 6 there. Okay, something of that sort. And therefore, what are the answers to this question? No matter what you do, this is brilliant stuff. And we're able to see, therefore, that the answer to this would be x between 3 and 6. X between 3 and 6. X between 3 and 6. The many ways, yeah, because of the transformation that we are seeing there. There are many ways to do this question, but you're analyzing this in terms of a translation. A translation of f of x, of f, just of f, by 3 units to the right. Okay, it yields the result. I mean, the translation is also called the transformation. It's also called a transformation. Okay, so we look at the next point. Right, and to solve the next problem, we're going to look at 1.3. Right, in 1.3, I mean, there are a couple of things that remain important. The sum of two numbers is minus 10, and the product of the same numbers is minus 600. Determine the value of the two numbers. You can guess this one for 5 marks. They don't want to do this at grade 10, at grade 11, at matric. They just have that one word sum, one word problem, and they ask you to solve the word problem. Let's take a look. So if the sum of two numbers is minus 10, so you let x and y be the numbers, be the two numbers. Let x and y be the two numbers. We get the sum because it's the sum of the two numbers is minus 10. So in other words, if you add the two numbers, you get minus 10. And the product of the same numbers is is minus 600. Okay, you see now, I'm doing this with you. I'm doing this for you. And you need to have your own time and to do this during your own leisure, you know, and and give the answer so that you can see what to do. We can see how well you improve. I'm just teaching, talking. Okay, now at this point, x equals minus y minus 10. You can have that one. By transposition, we can move y to the other side, making it negative. So, and then it becomes minus 10, minus y minus 10. Call this one the first equation and call this one the second equation. Substitute equation 1 into 2. Okay, substitute equation 1 into equation 2. Substitute equation 1 into equation 2. Okay, so it's minus 600. Okay, x is minus y minus 10. So if there's x, you put minus y minus 10. Y equals minus 600, which means that you have minus y squared minus 10y equals minus 600, which means that, okay, you transpose these ones to the other side, giving us y squared plus 10y. Okay, y squared plus 10y minus 600 equals 0. Okay, we have a chance, but a perfect chance to factorize this here, which means you have y squared plus 10y minus 600 equals 0. Okay, and so we need to factorize this. And to factorize this right now, we look for the factors. I'm not going to waste a lot of your time, but this one is easy. The factors of minus 600 that give 10 are y minus 20 together with y plus 30. Minus 20 and 30 give us minus 600, yet 30 minus 20 is 10. And the result is 0, meaning y is 20 or y is minus 30. Okay, pay particular attention to that and make sure you understand that. So we move then forward to analyze this even much further. Now, if we have this, so x is what? Is minus y minus 10. So at this point, if you do substitution, x equals minus, what is y? Is minus 20 minus 10, and this is minus 30. Or x equals minus y minus 10, but the y is minus 30, so is minus 30 minus 10, and therefore x is 30 minus 10, and 30 minus 10 is what? Is 20. Okay, we're able to see that we have the following answers here. Wherever we have y equals 20, wherever we have y equals 20, x is minus 30. So we got y equals either 20 or minus 30. All right, so that we have x equals, and x equals exactly 20. So minus 30 and 20, 20 minus 30. And that's the answer to the question. Right. 20 minus 30, and 20. So we proceed to solve the next one. Right, so in the next question now, we need to simplify completely without the use of a calculator, and we have the following radical equation. We have the following radical equation. In this radical equation, we are expected to solve completely without the use of a calculator, so we give in this expression and let's proceed to solve. Right, to solve this one here, we have 2 times the square root of 8 minus 4 times the square root of 32 plus 3 times the square root of 50. Pay attention. What is the square root of 8? It's 4 by 2 because 4 is a perfect square and therefore has a rational root, a rational square root. 32 is actually 16 by 2, perfect, because we know 16 is a perfect square and therefore has a rational square root. 50 is 25 by 2 because we know the rational square root concept. We break these down to square root of 4, square root of 2, square root of 16, square root of 2, 3. Square root of 25, square root of 2. And therefore, this is the square root of 4 is 2. Square root of 2, 4. The square root of 4 is, the square root of 16 is 4. So square root of 2, 3. The square root of 25 is 5 times the square root of 2. 2 by 2 here gives us 4. The square root of 2, 4 by 4 is 16. The square root of 2. Okay, here, when I have exactly 16 minus 16, the square root of 2, 3 by 5 is 15. The square root of 2, like so. And therefore here you have 4 minus 16, which is a minus 12, plus 15, which is actually a 3, the square root of 2. And that's the answer. And that's the answer. And we've been able to simplify completely without the use of a calculator. And this is the answer here. And we're done. Okay, we move on to the next question. The next question involves indices and exponents with negative indices, etc. Let's proceed to check that on that part of the question paper written in June 2022. Right, if you look at the 2.1.2, you have 3 to the power minus 1/2. That is the question, the square root of 12. And then we have the cube root of open bracket 3 times the square root of 3. Like this, close bracket. Okay, what do we do here at this point? We have 3 to the minus 1/2, like that. Now we are dealing with what is actually happening here. And the couple of things we surely can do at this particular point. And it appears now we have a tug of war on ideas and expressions, because this is to a negative power, 3 to the power minus 1/2. What about 12? 2 squared times 3 to the power 1/2. This one is 3 times 3 to the power 1/2, 1 out of 3. Okay, because this one is a cube root. Can write like that. Getting 3 to the power minus 1/2. So this one is 2 to the 2. Okay, we're smart. So this one is going to be 2 to that. Let me just write that step. It's a trivial step, but we can write like this. Plus 3 to the 1/3, 3 to the 1/2, 1/3. Okay, using the law of exponents, ab to the nth power is a to the nth power b to the nth power. This becomes 3 to the minus 1/2. 2 cancels 2, giving us 2 to the power 1. 3 to the power 1/2 plus 3 to the power 1/3 times 3 to the power, this one here. What is this? What is this? This is 3 to the power 1/6. Okay, because 2 times 3 is 6. 1 by 1 is 1. Right, at this point, you multiply straight away. And if you do that, you have 2 to the power 1, 3 to the power. So if you multiply here, you add the exponents. So it's going to be 1/2 minus that. And then you have 3 to the power. Okay, obviously here you have the bases are the same here. If the bases are the same, you add the exponents. You have 1/3, 1/6 minus 1/2. 1/3, 1/6 minus 1/2. Okay, we continue. So this is 2 to the power 1, 3 to the power 0, because 1/2 minus 1/2 is 0, plus 3 to the power. Okay, you have everything here. Let us check the top here. 6 divided by 3 is 2 by 1. 2 plus 6 divided by 6 is 1 by 1. Minus 6 divided by 3 by 2 is 3 by minus 1 is minus 3. And this one is 2 plus 3 to the power. 3 minus 3, 0. Okay, everything becomes 0. And therefore, this one here is 2 plus 1, and 2 plus 1 is a beautiful 3. And 3 is the answer. And 3 becomes the answer to the problem. And 3 becomes the answer to the problem. So we look at the next question. We look at the next question. So the next question is as follows. The next question is as follows. Right, you're looking at 2.1.3. Right, in 2.1.3 now, we need to simplify this one here. And this one is a very, very nice and easy question to simplify. Let us take a look and simplify this. So the first question is 5, or the question is, first and foremost, it is 5 to the power 2006. 5 to the power 2004 plus 24, all divided by 5 to the power 2004 plus 1. There are too many things to be done here. And one of the easiest things we can do is to take out 5 to the power 2004, open bracket. 5 to the power 2 minus 1 plus 24, all divided by 5 to the power 2004 plus 1. Okay, this is exactly the same as what? Right, so 5 to the power 2004. This is 5 squared minus 1, which is 25 minus 1, 24. Plus 24 all over 5 to the power 2004 plus 1. Okay, 24 is a common factor. 5 to the power 2004 plus 1. All divided by 5 to the power 2004 plus 1. Okay, so we are looking at this part here. So these cancels, and the answer is clearly a 24. And the answer is clearly equal to 24. And we have seen before that 24 is the answer to the question. All right, look very carefully at what we've done and how we simplify this problem, but very, very straightforward. It would be interesting to try these questions during your own leisure. I'm going to post this on the WhatsApp group, and you can spend time to practice this step by step and see how well you can perform and how well you can be able to solve these problems. Next, we solve the next question. Right, so in 2.2, then we have 2.2.1. You need to write x squared in terms of x. need to write x squared in terms of x. Then to write x squared in terms of x, we have the following. Right, first things first, we know that we've been given so we're looking at 2.2.1, we've been given x equals the big square root. 6 plus another square root. 6 plus another square root. 6 plus another square root. 6 and so on. So what we do, we take this because of the square roots. So we're going to square on the left. And also, we're going to proceed to take the square root here, the square root here, the square root here, the square root here, and so on. And we square both sides. And if you square both sides, then you have x squared is equal to, this square is going to remove the topmost square root, leaving this like an umbrella, and the umbrella is gone. And now you have the inside open and exposed. So you have 6 plus. You have 6 plus the square root of 6 plus the square root of 6 plus the square root of 6. And this is going on. Okay. Now you know that the square root of 6 plus the square root of 6 plus the square root of 6 equals x, and therefore this is x squared equals 6 plus x. So write x squared in terms of x. So this is actually x squared equals 6 plus x, and that's therefore the answer to 2.2.1. Take your time to think of this, try to internalize this and make sure you understand. Because the next question is just like the first, and it requires us to solve for x. Now in 2.2.2, hence determine the value of x. We want to determine the value of x in this case. And to determine the value of x, we have the following. Right, so to determine the value of x, we have actually x squared equals 6 plus x. And when to determine the value of x for 4 marks, we need to solve for x. This is x squared minus x minus 6 equals 0. And this is actually minus 3. X plus 2 equals 0, which means x is 3 or x is minus 2. And this is the answer. So determine the value of x, and we can see that x is 3 or x is minus 2. But since x is actually equal to positive square roots, it means we can certainly say that x is not minus 2. But also, you see, these square roots, like you're having an infinite number of square roots. Okay, now having an infinite number of square roots means, therefore, that all the square roots themselves, if you add all of them, the answer is just 3. The answer is just 3. Right, so we continue to solve more problems, and we look at the next question, which is 2.2. We've already solved, and we look at the next question. The next question is 2.3, given rectangle PQRS with QR. Right, QR is actually the square root of 8 minus 1. RS is the square root of 8 plus 1. Determine the length of any diagonal of rectangle PQRS. Determine the length of any diagonal. Right, leave the answer in simplet set form. Right, so the couple of diagonals you can consider. You can consider that diagonal there, but also you can consider this diagonal over down here. Now, and find the length of each one. Obviously, we know very well that what we're dealing with is a rectangle, and therefore the interior angles of a rectangle are all right angles. And this is pretty straightforward and very obvious. But how do we then make use of this important result? We proceed to use what we call Pythagoras. If we have right-angled triangle, right, so if we have right-angled triangles, we use what we call a Pythagoras theorem. Right, so using Pythagoras, we're able to see that we have the following. Pythagoras says that x squared plus y squared is r squared. This you can view as, because it's vertical, it's y, and this is horizontal, it's actually x. meaning the x is the square root of 8 plus 1. The x here is the square root of 8 plus 1. So in other words, wherever there is x, we're going to put the square root of 8 plus 1. You square this. The y is the square root of 8 minus 1. You square this, and the result is r squared. And this r squared here, you can view it as a diagonal. What diagonal would that be if we confine ourselves in a specific triangle? Now, often than not in exams, it is very important to tell the examiner the triangle you choose to work in. So we're going to say in triangle RQS or in triangle QRS. Like so. Right, giving us exactly what we want. So if you have the x squared plus the y squared, it is equal to QS squared. So if you square this one here, which means that you have 8 plus 2, the square root of 8 plus 1 plus 8 minus 2, the square root of 8 plus 1 equals QS squared. Okay, now there are a couple of things that remain key to us. These guys cancel out. 8 plus 8 is what? It's 16. And 16 plus 2 is what? It's exactly 18. So with 18 equals QS squared. Okay. Now, what then are we able to achieve out of this? We square root the left, but we also square root the right-hand side. Upon careful examination, we have the following. Right, so we have the square root here of 18, which is actually the same as what? Now, 18 can be seen as exactly 9 by 2, and this is the square root of QS squared. What is the square root of this? So it's square root of 9, square root of 2 equals the square root of QS squared is actually the same as QS. Okay, now let's analyze square root of 9, which is actually 3 the square root of 2, and this is actually QS. Pay attention right now as we get to the depth of this. We're able to see, therefore, that this is exact. Now, remember that you must leave your answer in simplest set form. And therefore, the conclusion is therefore that QS, which is indeed a diagonal, is 3 the square root of 2. But remember that these diagonals themselves are actually sides and dimensions. Because their dimensions, they are sides of a triangle, and they are measured in units with length. So it is 3 to the square root of 2 units. 3 to the square root of 2 units. So, I mean, leave your answer in simplest set form. Any diagonal, we found the diagonal QS, but obviously the diagonals of a rectangle are equal to each other. So this one is 3 to the square root of 2, but the other one is also 3 to the square root of 2. So these diagonals are of equal length each. We're done. And once again, for anyone who is going to even watch this video a little bit later on, they might be able to understand what the objective was. And also, they might be able to understand what we wrote here. So it is 3 the square root of 2 units. And we're done. Let's go to the next point. Right, in the next question, we want to deal with the number patterns. Let's deal with number patterns. Right, now the first 4 terms of a quadratic number pattern are -7, 0, 9, and 20. We're interested in solving these step by step. Let's proceed to solve this one. Determine a formula to represent the general term of the pattern. All right, we are interested in a formula to represent the general term of the pattern. Now, a formula is always very, very palatable for us, and we spend some time to analyze that. Take note of the fact that we're answering question 3.1.1 at the moment. Right, we're going to start with the number pattern, actually -7, 0, 9, and 20, and so on. And we're going to actually now be in a position to say 0 minus into minus that, which is 7. 9 minus 0 is a 9. 20 minus 9 is actually 11. You have these two. 9 minus 7 is 2. 11 minus 9 is 2. Right, so you have 2a equals 2. And then you have 3a plus b equals this. You have a plus b plus c equals this. Okay. Now, always to find a formula, we do this with our number patterns. Now, we have actually the fact that our 2a equals 2. You divide the left by 2, the right by 2, which means a equals 1. Now, and what else do we have? We have that 3a plus b equals 7, and we have 3a is 1 plus b equals 7, which means b is 7 minus 3, which means it is actually 4. We have got b equals 4. And we have the last but not the least, which is the a plus b plus c equals actually minus 7. Take note of the fact that this is the first term of the quadratic number pattern. So we have a plus b plus c, and this equals minus 7. Always when dealing with quadratic number patterns, this procedure is the same. Take note of how we realize the second differences in the pattern, right? So we have the second differences here, and here we have what we call the first. We have the first differences. And look at how we handle these differences, but also look at how we handle the first term of the quadratic number pattern. A plus b plus c equals minus 7. What is our a? Our a is clearly 1. We got it here. Right, and our b is equal to 4 plus c equals minus 7. We want to solve for c, which means c is minus 7 minus 5, and this is minus 12. To get the general formula, we need a formula. We use the formula t subscript n equals an squared plus bn plus c, and this means that tn equals, what is our a? A is 1. Which means it's n squared. Our b is 4n. Our c is minus 12. Our c is c is minus 12, and therefore this is the formula. It is n squared plus 4n minus 12. Take note of that. The answer, we have the answer there. Okay, right. We proceed right now to answer the next question. Which term of the pattern has a value of 128? We look at that one. Right, at this point, we know very well that this is actually equal to n squared plus 4n minus 12. Which term of the pattern has a value of that? So there's a specific term that is 128, but we know that the general term, the formula, is n squared plus 4n minus 12, which is n squared plus 4n minus 12 equals 128, which means n squared plus 4n minus 140 equals 0, which means you have n minus 10, can factorize this, and then n plus 14. I'm not wasting lots of time with the factorization part. Upon careful examination, we're able to see that n is going to be exactly 10 here, or n is equal to minus 14. But obviously, because which term we're dealing with, the number of terms, we can clearly see that the number of terms cannot be negative. So the number of terms is only 10. And therefore, which term of the pattern is the value 128? It is the 10th term of the pattern. The next point. Right, so we look at 3.1.3, determine between which successive terms in the quadratic number pattern will the first difference be 599. So now if you have to determine between which successive terms in the quadratic number pattern will the first difference be 599. So now look, you are dealing with which successive terms in the quadratic number pattern will have the first difference be this. The first difference is that one. So now you are dealing with the first differences. Right, so now how do you therefore deal with the first differences? So we will take note of the fact that obviously it's for 3 marks. So you have minus 7, just writing out the quadratic number pattern, 0. Okay, I'm going to pose these questions again on the WhatsApp group. Now, for you to learn and understand these things, you need to do these questions again on your own. Okay, now you're watching me, but I'm going to pause the question because this is like a full question paper that I'm doing. So I'm going to pause this question paper there. You need to go through it. The answers are on the videos. Most of the questions I sent there on the WhatsApp group, I've already solved them on the videos, and you just need to watch the videos again to see what needs to be done. Okay, only a few questions have not been solved. So yeah, you need to take the questions on the group and solve. Right, so but now these questions are determined between which successive terms in the quadratic number pattern will have the first difference. Okay, let's deal with the first differences. Just the first differences. Right, obviously we're going to deal with multiple of them, but we have the following here. Right, so if you're dealing with the first differences, we have this minus that, which is actually 7, 9 minus 0, it's a 9, 20 minus 9, it's exactly 11. These are the first differences, but these first differences themselves form an arithmetic because 9 minus 7, it's 2, 11 minus 9, it's 2. Right, so this becomes an arithmetic with the common difference to an arithmetic progression. Right, meaning, therefore, with an arithmetic progression, I want to write something here, arithmetic progression. Right, so dealing with what we call an AP, and this AP is an arithmetic progression. Okay, now take a look at the arithmetic progression and think. The general formula for the arithmetic progression is a plus n minus 1 times the common difference. Tn equals, what is the first term? We're dealing with the arithmetic, and therefore the first one is 7. N minus the constant difference, or the common difference, is a 2. Tn, therefore, is 7 plus 2n minus 2, and this is Tn equals 2n plus 5, like this. Okay. Now, with this then in mind, we continue to analyze this, but pay particular attention to this as a grade 11 child. But dealing with quadratic number patterns is it's standard procedure, so this does not change in any way substantially or in any shape or form. Which term, so determine between which successive terms in the quadratic number pattern will have the first difference be this, the first difference. Okay, this is the formula for the first differences. The first differences have the formula twice n plus 5. But you see, we think about this, and we are then saying here, our Tn is equal to 2n plus 5, and this difference is 599. Which means Tn is 599 minus 5, which means 599 minus 5 is what? Is 594. Okay. And then 594, you take 2n, you divide the left by 2. 594, you divide both left and right by 2, meaning n is 594 divided by 2, which is 297. So now it means this difference will be between term number 297 and term number 298. So we then say that this difference, so it's the answer to question 3. So this, to question 3.1.3, this difference, right? So what is the term n equals 297 mean? What does it mean? It means this difference will be between term number 297 and 298. Okay, this difference will be between term number 297 and 298. Okay, now, I mean, there's something you need to consider here. If the term number 2 here. This one is T2, and this one is T1, and this one is T3. Writing like here. T3 in the phase differences, in the sequence of the phase differences. But let's analyze and look at what that means. So term 1 here is between what? It is between, this is term 1, this is term 2, this is term 3, and this is term 4. Look, term 1 is between term 1 and term 2 of the quadratic. Term 2 is between term 2 and term 3. Term 3 is between term 3 and term 4. So term 1 is between term 1 and term 1 plus 1, which is term 2. Term 2 is between term 2 itself and term 2 plus 1, which is term 3. Term 2 plus 1, term 3. Term 3 is between term 3 and term 4, which is term 3 plus 1, which is term 3 and term 3 plus 1. Okay, now this is something that is very important, which is something that is very, very important to this pattern, even at metric. These things are there at grade 11, they're there at metric. So, yeah, you need to, but now this question was set for the grade 11 learners. So, yeah, so if you get n equals 297, it means what? It means this term, if this one is to do with the arithmetic progression of the phase differences, if you get term number 3 is between T3 and T4. So if you get 297, this difference will be between term number 297 and 298, like we can see here. Okay. Because they said determine between which successive terms in the quadratic number pattern would the first difference be this. Okay, so now we're dealing with the first differences, and now there's a first difference that is 599. So since n is 297, it will therefore be between 297 and 298, between term number 297 and term number 298. Hope you understand that. Next point. I want us to consider the next question. Given the quadratic number pattern 5, 12, 29, 56, write down the next term of the pattern. Write down the next term of the pattern. Given the quadratic number pattern 5, 12, 29, 56, write down the next term of the pattern. Right, what is the next term? Remember, it's a quadratic number pattern. So now to write this one, there are a couple of things you need to obviously take into account. You need to note that we're dealing with the differences here, and if you say 12 minus 5, you get a 7. 29 minus 12, you get exactly a 17. And therefore, if you subtract these two, what do you get? You have a 56. And if you have a 56 and you subtract a 29, what do you get? Right, so if you have 56 minus 29, you have actually 27. And you subtract here, you get the differences here. You have 17 minus 7, you have a 10. 27 minus 17, you have a 10. Okay, obviously showing that it's quadratic because the second differences themselves are constant, all 10. Now, you need to write down the next term, and the next term can be written with so much ease and simplicity. These will always be 10 all the time. So now you add 10 plus 17, you get 27. 27 plus 10, you get 37. Right? So then now to get this one, you said 12 plus 17, you get that one. 27 plus 29, you get that one. 37 plus 56. Right, so what is 37 plus 56? Or 56 plus 37? Right, so you add 50 and 30, you get 80, and you have 6 and 7, it becomes 13, and that is 93. So yeah, just say write down the next term of the pattern. It's actually 93 there. It's 93. It's 93. Now we continue to solve more problems. And you look at the next question as we solve the simple step. We look at 3.2.2. Show that the first differences of this pattern will always be odd values. Show that the first differences of this pattern will always be odd values. So let's check that one. Okay, in 3.2.2, well, it will always be odd values. But now the first differences. So now we must deal with the first differences like we've done before. So we deal with 5, 12, 29, 56. And you have this one here, which is a 7, which is 12 minus 5. And we have 29 minus 12, which is a 17. And here we got a 37. Okay. And 17 minus 7 gives us a 10. 37 minus 17 gives us also a 10. Excuse. Okay, there is a small little error here. This one must be 27, 17, 27. Right, 17, 27. Like so. Okay, so now if you have 17 minus 7, get a 10. 27 minus 17, get a 10 as well. Okay, good. We get a 10, 10. Take note of that. Okay, now let us pay attention to this and analyze this. Because the examiner is saying show that the first differences of this pattern will always be odd values. So these first differences, you can see the first differences. These are the first differences. All right, so the first differences, you can also write first differences. Okay, first differences. Now I want us to, to analyze this. First differences. This one gives us second differences. Okay, now your second differences, first differences. Show that the first difference with this pattern will always be odd values. So if the first difference is, now we can see there are 17, which is an odd number, rather 7 is an odd number, 17 is an odd number, 27 is an odd number, and so on and so forth. Now the question would then become, you need to show that these will always be odd values. So yeah, it makes sense to deal with the general formulas. So we know that these are arithmetic, so they form an arithmetic progression, which is a plus n minus 1 times d. What is the first term of the arithmetic? It's 7. N minus 1, the common difference of the arithmetic is 10. Right, like so, so that you have this one here is actually 7 plus, distribute here, 10n minus 10. Okay, it's 10n minus 10. 10n equals t sub n equals exactly 10n. Okay, so yeah, this one is t sub n. Right, so t sub n equals exactly 10n. Now 7 minus 10 is minus 2. Okay, this, no, is minus 3. Okay, this one, please, it's minus 3. 7 minus 10 is a minus 3. Just take note of that. Okay, so that in the end, then Tn equals 10n minus 2 minus 1. Okay. And then we have Tn 2, which is the same as 5n minus 1 minus 1. Okay, because 2 is a common factor. It's the highest common factor. So the highest common factor is 2. in these first two terms, in these two terms within the parentheses here. So we have 2 open bracket 5n minus 2 close bracket. Right. So, and what we're able to see is thus the 10n minus 2 is effectively equal to 2 open bracket 5n minus 1. Yet we make the observation that 10n minus 2 is even for any value of n. Is even for any value of n. Is even for any value of n. Tn is odd. Tn is odd. Is odd when Tn is odd when Tn is going to be 10n minus 2 minus 1. Okay, because we realize that this one is even, then if you have an even number, subtract 1, then it's going to be an odd number. So that's the reason. Because if you have an even number, 6 is an even number, subtract 1, it's going to be 5, which is an odd number. You have another even number, 8, if you subtract 1, it's going to be 7, which is an odd number. So you have these odd number patterns that sort of emerge out of this. Okay, yeah, but yeah, take note of these things and we continue. Right, if you look at the next first thing, question 4, given the linear pattern, which is 1 minus p, 2p minus 3, p plus 5, calculate the value of p. But obviously, this one is a linear pattern, and linear pattern is an arithmetic. Pattern. Okay, sometimes I'm going to ask you in the group to do these things, and you send them to me, and I mark so that I can be sure that you follow these things and you understand. Because if they then say, calculate the value of p, okay, in an arithmetic pattern, we have the following. Right, obviously, see, we're in an arithmetic pattern, guys, there are a couple of things that need to take into account. The arithmetic things that need to take into account are the fact that arithmetic progressions themselves have a first common difference, and we will note that. Hello, my dear. So you have a 1 minus p there. Yes, my dear. Yeah, my dear, after my class. Yeah, after 10. Yeah, after 10, so that we can make a plan, my dear. Okay. All right. Okay. Thanks, my dear. So So we have 1 minus p, 2p minus 3, and we have p plus 5. So we need to calculate the value of p. So right. So at this point, you need to calculate the value of p. So you can just find these first differences here. So you'll say like 2p, the whole thing here minus the whole thing there. So you can say 2p minus into minus p. So it's going to be like 3p. Minus p minus 1 is a minus 4. P minus 2p, which is a minus p. 5 minus into minus 3, which is plus 8. Okay, it's linear, so you don't continue. You just stop at the first differences. Right, so if you stop at the first differences, there are a couple of things you need to take into account. So you need to calculate the value of p, but because the differences themselves must be the same if it's arithmetic, so it means that 3p minus 4 must be equal to minus p plus 8, because it's arithmetic, so these things must be, the first differences must be equal to each other. So we continue. Right, so yeah, we collect like terms. So this is actually 3p plus p giving us a 4p, and this is 8 plus 4 giving us 12, which means 4p equals 12. Divide by 4 both left and right, which means p equals 3. Calculate the value of p, and we can see that p equals 3. All right, so we continue. So now at this point, okay, right, we have right. So obviously, we have to calculate the value of p, and we can see that p equals 3, and we have the following. We have the following. So right. Now, so right. So we have p equals 3 here. Write down the value of the first term of the pattern. Write down the value of the first term of the pattern. Right, so if you write down the value of the first term of the pattern, right, we already know that here p is equal to 3. So we can just substitute the value there. So now, for instance, the first term is 1 minus p, which is 1 minus, the p is 3. 1 minus 3 is minus 2. So the first term of the pattern is T1 equals minus 2. What is the common difference? What is the common difference? What is the common difference? Right, so the common difference at this point is what we can get. And the common difference can be seen with so much ease. So to find the common difference, you just need to get the first two terms and subtract them from each other. Let's proceed with that part of the question. So now looking at 4.2.2, then we're going to actually have here 1 minus 3, 2 times 3 minus 3, 3 plus 5. So 1 minus 3 is minus 2, 6 minus 3 is 3, 3 plus 5 is 8. So you can find T1 is minus 2, T2 is 3. Okay, to find the common difference, by definition, the common difference is T2 minus T1. T2 is 3 minus into minus 2, and this is actually 5 because this is plus 2, which is a 5. So, and that tells us clearly that the common difference is a 5. Explain why none of the numbers in this linear pattern are perfect squares. Explain why none of the numbers in this linear pattern are perfect squares. But like none of them are perfect squares, why? The examiner is asking us this question. Why is it that none of them are perfect squares? Let us explain that when we explain that part. So to take our 4.3 now, let us look at the original pattern. 1 minus p, 2p minus 3, p plus 5, and so forth. Then we have 1 minus 3, 2, 3 minus 3, 3 plus 5, and so on. 1 minus 3 is a minus 2, 6 minus 3 is a 3, 3 plus 5 is 8, and so on. Okay, now we have this particular pattern. So explain why none of the numbers in this linear pattern are perfect numbers. Right, so all, this is the explanation. So we're able to see that all, right, all the terms. Right, so we say that all the terms except T1 and in either a 3 or an 8. Okay, all the terms end in 3 or an 8. Now, I want us to observe something, that at this point, you can even extend the pattern because this is minus 3, then it becomes minus 2, then becomes a 3, meaning 5 was added. You add 5, 5 plus 3, you get 8. You add 5, you get 13. You add 5, you get 18. You can add 5, you get 23. So all terms except T1, except the first one, end in either a 3 or an 8. Right, a 3 or 8. 3 or 8. Okay. While perfect numbers, while perfect squares, while perfect squares end in 0, 1, 4, 5 like 25, 6 like 16, 9 like the number 9, which is 3 squared. So yeah, these are perfect squares. They end in this. And that is the reason. So perfect squares end in this, but these numbers end in either 3, 8, 3, 8, 3. So that is why that is the expression to justify why none of the numbers in this linear pattern are perfect squares. Let's look at the next problem. Right, so we continue to look at the graphs and functions as they form part of the curriculum, but also the graphs and functions themselves are very important, integral part of the grade 11 curriculum. So this grade 11 curriculum is very, very important curriculum. Now, the graphs of f of x equals ax squared plus bx plus c, a not 0, and g of x equals 6x plus k are drawn below. Here are the graphs. Point D with the coordinates 1 minus 8 is a common point on f and g. So point D is a common point on f and g. F intersects the x-axis at minus 3 and 0, right, and 2 and 0. Right, G intercepts the graphs of F at D only. Okay, the point of intersection is D only. You can see that. For which values of X, values of X is the F function. In other words, the parabola less or equal to 0. So now you're able to see that it is less when it is negative here, it is positive there. So it is positive here and it is positive there, and it is sort of negative in the middle, right? So for the values of x is the negative or 0, so it is equal to 0 here, and it is negative all the way down here. So we're able to see clearly, therefore, that it is between negative 3 and 2. It is between negative 3 and 2, right? So, I mean, the couple of things, therefore, that remain very important. So the answer to 5.1 would be between minus 3 and 2. That is when this is greater or equal to 0, less or equal to 0, excuse me. But we can also investigate where we're interested in parts where this is greater or equal to 0. The greater or equal to 0 parts, for instance, would be when x is less or equal to negative 3, or x is bigger or equal to 2. X be equal to 2, it is greater than 0 over there. Okay, so we continue to analyze the next question. We look at 5.2. Right, in 5.2, we need to determine the values of A, B, and C. Right, so we need to find the values of A, B, and C. Very, very straightforward, but with a chance to learn a new formula, I'm here to spend a bit more considerable amount of time on quadratic functions and graphs and functions from the basics to the top. But I want to spend time on graphs alone. I'm going to dedicate days and days to do graphs. Only graphs, to make sure you master this. But as a formula we use when we're given the x-intercepts and we need to find the equation. Okay, they can ask you this one time tomorrow. Given the x-intercepts, you need to find the equation. Use the formula x minus x1, open bracket, x minus x2, which means that y equals... Okay, I'm going to speak a mouthful about the quadratics here, and in view also of the notion of the turning points, I'm going to speak a mouthful. So at this point, you have a open bracket x minus x1. So x1 is minus 3 and x2 equals 2. So x1 would be minus 3. So you put a minus 3 like this, and x2 becomes a 2. This is x plus 3, x minus 2. Okay, right, we have this. And then now we need to realize, okay, it's not enough because we need to find the value of A. So the value of A has not been found. So we must realize, therefore, that this graph passes through. It actually passes through the point D. We need another point, an extra point, because we use the x-intercept, but we must use now the point D with the coordinates 1 and -8, which means you have x and y. So which means you have -8, which is actually 1 plus 3, 1 minus 2, which is -8 equals, what is 1 plus 3? It's a 4. 1 minus 2 is a -1, which is -4 equals -8, which is this, which is -8. We have -4, which means A is equal to 2. Okay, if A is equal to 2, then it means, therefore, you can write the answer. You put a 2 there. So you have 2 outside here, and you have exactly x plus 3, open bracket, x minus 2, x plus 3, close bracket, open bracket, x minus 2. Okay, now look at that and think carefully about this. But now I want us to quickly perform distribution here. And we want to just find the values of A, B, and C. So let us write these here. So we move these to the top like here. And this is actually y equals 2, open bracket, x plus 3x minus 2. And this is y equals x by x is x squared. X by -2 is -2x plus 3, which is exactly plus x minus 6, because 3 times -2 is a -6. And then we have y equals 2x squared plus 2x minus 6, like so. And we want to find the numerical values. So we're able to see, therefore, that A is 2, B is 2, and C is -6. Right, so we need the numerical values. We can see that actually here, A is 2, B is 2, C is -6. Okay, these are the numerical values. Give them some thought and make sure you understand these, because this is, let me see. Okay, it's a -12 here. 2 times -6 is -12, please. Right, so, right, 2 times x squared is 2x squared, 2 times plus x is plus 2x, 2 times -6 is a -12. So 6 becomes, C becomes -12. -12, like so. Like so. Okay, so the next thing is that you need to determine the coordinates of the turning point of F. Determine the coordinates of the turning point of F. All right, to determine the coordinates of the turning point of F, like turning point is sitting here. I'm going to teach you 2 formulas to find the coordinates of the turning point, but you can use many other ways to do that. So, as a grade 11 child, you need to know that given a parabola, whose equation you already know, you already said it is exactly 2x squared plus 2x minus 12, giving us A equals 2, B is 2, C is -12. Two cancels, giving us 1/2, which is 4ac minus b squared over 4a. A is 2, C is -12, B is 2 squared, A is 2. Okay, let's check the top. What is 4 times 2? 4 times 2 is 8. 2 times, yeah, what is 8 times 12 minus, which is, yeah, minus, so it's going to add up. Right, I need to just do this one quickly. Right, so we have 4 times 2 times 12 with the 4. Right, what we're getting at the top is actually -100. You're dividing that by like a 4 by 2, which is exactly 8. Okay, pay particular attention to that part, because if you divide this, then it becomes what? Okay, first you divide by 4. which is 25 out of 2. And 25 out of 2, 2 goes how many times into 25? It divides 24, going 12 times, remainder 1 out of 2. Right, so the turning point. Right, so we're interested in the coordinates of the turning point. So the turning point would have the x component, which is the abscissa, minus 1/2, and the ordinate, which is minus 12 and 1/2, like that. But you see, I mean, I'm using the formula for the turning point. These two formulas are for the turning point. X equals to minus b over 2a for the turning point. I'm teaching these formulas. And the other one is y equals 4ac minus b squared over 4a. Is also the y coordinate of the turning point. Now, I mean, these are very important things that you need to take note of. But if you have y equals the function 2x squared plus 2x minus 12, what is the x? It's minus 1/2. X is minus 1/2 minus 12. Then when you add everything here, let's just simplify this together. Right, so at this point, you square the minus 1/2, getting 1/4. And then here you cancel everything. You have a minus 1 minus 12. 1/2 minus 1 minus 12. What is half minus 1? Minus 1/2 minus 12. Minus 12 and 1/2. So it's minus 12 and 1/2. So you can just use the formula x equals to minus b over 2a and get the value of x, and then substitute into the original quadratic to get the corresponding y value for the turning point. Or you can use this formula for the turning point, for the y value of the turning point, and you can use this formula for the x value of the turning point, and you're able to get these two values there. Next question. Write down the equation of the axis of symmetry of h if the h of x is equal to this. Write down the equation of the axis of symmetry of h. So now, right, so in the end now, the axis of symmetry, we know very well, but now it is of this. Right, remember that we already got the axis of symmetry of this one, and the axis of symmetry of this one is x equals minus 1/2. But if we are to consider axis of symmetry of this one, which is f of x minus 7 plus 2, then it means that it is the axis of symmetry of a graph that is translated twice. But the only translation that is going to matter is this one. This one is like 2 units up. So this one means 7 units. 7 units right. Right, so 7 units right. Okay, maybe I can write something that is more correct in English terms here. So 7 units to the right. Okay, 7 units to the right and 2 units up. Right. So 7 units to the right and 2 units up. Now, let's look at this. What does this mean in terms of this? So if a graph has this x value as the axis of symmetry, right, as the axis of symmetry, so what then do we achieve now? We're going to then say, we're going to move this graph 7 units to the right. So if you move it 7 units to the right, there's something you need to take into account. So in other words, x is going to be, it was minus 1/2 before, but you're going to add 7 to it. You're going to add 7 to it. And if you add 7 to it, it's like 6 and 1/2. 6 and 1/2. And so now I want to write down the axis of symmetry of this one. If you move the graph 2 units upwards, it cannot change the axis of symmetry. So even if you move it upwards, this one, the axis of symmetry will still be the same. It will actually be 6 1/2 there. So yeah, pay particular attention to that and note that. Let's look at the next question, 5.5. Determine the equation of a line Q which is perpendicular to G passing through the point -3 and 0 in that form. Right, so determine the equation of the line Q which is perpendicular to G, right, and passing through the point -3 and 0 in that form. Okay, let us look at that one. Right, so G is this one, but you'll remember there's something I want us to recall. G has the equation -6x plus what? Plus K. Right, so G is the straight line that is 6x plus K. All right, so in other words, now, if you are to look at this one is G of X, something perpendicular to G is going to be the gradient of G times the gradient of the one that is perpendicular to G. The result must be -1. Well, the reason is that you have that the graph of G is perpendicular to the other one. Okay. Now, the graph of G has the gradient, this one. So the gradient of G is 6. So you're going to have 6 times the gradient of the graph perpendicular to G, and the result is -1. Divide both the left and right by 6. Which means that the gradient of the graph perpendicular to G is -1/6. We need to find the equation, but it is through. Okay, we already found the gradient of the graph perpendicular to G, but it is passing through this point. So it is passing through -3 and 0, giving us x and y. And this means that x is, okay, so you're going to use the formula y minus y1 is m open bracket x minus x1, like this. Okay. And therefore, if you have y minus y1 equals m open bracket x minus x1, y minus 0, and the gradient is -1/6 x minus times -3. Okay, because x is -3. So we are using this point. So y1 is 0. x1 is -3, which means y is, okay, so this is -1/6x. This is +3. And if you multiply here, it's going to be -3/6. This would give us, therefore, -1/6x minus 1/2. Okay, take note of that. And this is the equation we want. Okay, now what have we done here? We use the fact that if two lines are perpendicular to each other, if two lines are perpendicular, then the product of their gradients equals -1. But for parallel lines, right, but for parallel lines, the gradient of line 1 times the gradient of line 2, the result is -1 as long as line 1 is parallel to line 2. Parallel lines, guys, the gradient of line 1 equals the gradient of line 2. This is testimony to the fact that, or it is testament to the fact that you have that line 1 and line 2 are parallel to each other, and therefore, if two lines are parallel to each other, then we have that the gradients are equal to each other. Okay, so it's something that you need to take note of there. Okay, we continue to look at another graph question. All right, question 6 is on graphs, and the examiner decided to bring in 2022 for the grade 11 learners this particular function, which is an exponential function, but also they've given this particular function, which is the parabola function, or what also called the quadratic function. Sketch the graphs of P and H on the Same set of axes in your answer book. Indicate all intercepts with the axes and turning points. Indicate all intercepts with the axes and any turning points. Right, so to sketch the graphs of P and H on the same set of axes in your answer book, what do we do? Right, let us sketch these graphs on the same set of axes in the answer book, indicate all intercepted axes. Okay, very, very straightforward, these here. Okay, let us sketch quickly. Right, so we're going to look at 6.1. Let us draw quick sketches here, like so. Okay, this is the x and this is the y. Okay, the exponential function, this one here, it's a graph that is gonna, if you put x equal to 0, you have 4 to the power 0, which is 1. So it's gonna cut at 1 here. And it is said to be an increasing function. Right, it is an increasing function. Not just increasing function, it is an increasing exponential function. Right, it is an increasing exponential function. So something you need to take note of. Okay, now this one, this quadratic, is very interesting to us, but it has a vertex, also called the turning point. The vertex of the graph occurs at 1 and minus 8, where x is 1 and y is minus 8. X is 1 and y is minus 8. This graph here has, we must know the y-intercept. The y-intercept is going to occur when, right, we must know the y-intercept. So for the y-intercept, you let x be 0. So which means h of x is 2x minus 1 squared minus 8, which means 0 minus 1 squared minus 8. And then you have 2 minus 8, which is a minus 6. Which is exactly minus 6. Okay, pay particular attention because you have a minus 6 here. And this is the y-intercept. When x is 0, y is minus 6. So it's going to be exactly cutting through minus 6 here. Okay, which is 0 and minus 6. Okay, now there's something called the x-intercept. So with the x-intercept, you let y be 0 here, which means 2x minus 1 squared minus 8 equals 0, which means x squared is equal to 8 divided by 2, giving us a 4. Taking the square roots both sides, you have x minus 1 equals plus or minus 2, which means x is 1 plus or minus 2. Okay, let's look at these here. This means, therefore, you have 1 plus 2, or x equals 1 minus 2, which means x is 3 or x is minus 1. And obviously, this happens when y is 0. X is 3, y is 0. X is 1, y is 0. So x is 1, but also x minus 1, excuse. Okay, because 1 minus 2 is a minus 1. So it's gonna cut, therefore, at minus 1 and 3. Right, let me use the green color just to create a difference. Everything is red now. Right, so here 1 minus 2 is clearly a minus 1, so it's going to cut here, it's going to cut here, y-intercept, and it's going to just be like so. It's going to be like so. It's going to be like so, and this exponential is going to keep going up. It's going to keep going up. And now, you don't need to extend this very much. And you can sketch it like so, because the exponential rises so fast that if ever they're going to catch up, it will take a bit of time there. Okay. Right. So, and this is the 6.1 part. So we've indicated all intercepts with the x's and the coordinates of the turning points. This one is the 3 and 0. This one is -1 and 0. This is 0, -6. This is 0 and 1. Okay. Okay, next. Okay, sketch the graph of f if f is minus p of x. So you have that f is minus p of x using, yeah, sketch the graph of f if f is minus p of x using the same set of x's as in question 6.1. Okay, so you're going to just sketch that one, but now we are having the f is the negative of this. So let's just look at what this means. So if f of x is p of minus x, it means that for wherever there is p here, wherever there's x, you put minus x, so it's going to be that one, 4 to the power minus x. 4 to the power minus x. Okay, pay particular attention to this. So what kind of a graph is 4 to the power minus x? So if you need to sketch 4 to the power minus x, when x is 0, it's going to be 4 to the minus 0, which is 1. 4 to the 0 is 1. And then it's going to still cut at 1 here, but this one is going to be like this. Okay. So it becomes the mirror image. It becomes the mirror image of the exponential p, because this is p and then this is the other graph, which is f, which is minus f of x, which is equal to p of minus x. Okay, something that you need to take note of there. Something that you need to take note of. Something you need to take a particular note of. Okay, yeah, sketch on the same set of axes. So this one is the graph of f, where f of x is p of minus x, but we've already seen, I mean, the f of x equals equals 4 to the minus x. Okay, just note that, and we've graphed these they're on the same set of axes, and it is all good and well. Next point. Next point. Okay, let's continue and see what else we have to do here. Okay, 6.3, the graph of h is shifted. So obviously we have the graph of h, and h is this one, which is 2, open bracket, x minus 1 squared minus 8. But let's look at the shifts. All right, so h is 2x minus 1 squared minus 8. Okay, but now the graph of h is shifted 2 units to the left. Write down the equation of the new graph. Okay, so if it's 2 units to the left, so it's going to affect the x, right? Because up and down affect y, but left, right affect x. So 2 unit left would actually mean the following thing. Right, so it means therefore that you need to add and then to go to the left. Right, so you add to x, and wherever there's x, you put +2, and then it's going to go 2 units left. Right, so that is exactly what we have. And then the new graph is going to be, okay, we're looking at 6.3, remember? Right, so it's going to be h of 2 equals 2 open bracket, 2 minus 1 is actually a 1, you square that minus 8. Right, and that is the answer. So write down the equation of the new graph. Okay, you can write the new graph as h of x plus 2, and this is 2 open bracket x plus 1 squared minus 8. And this is nothing other than 2 units left. Show algebraically that p of, show algebraically that p of x plus 1/2 is 2 px. Okay, let's just show using algebra. So now we're gonna take the function p. We remember that the function p of x is 4 to the power x. I'm not just inventing this, but we're given that p of x equals 4 to the power x. We're given that. So p of x equals 4 to the power x, which means that we have x plus 1/2, which is 4 to the power x plus 1/2. So, and like I said before, when dealing with exponents, is always your hint to make sure that you split the powers like that, so that this is 4 to the power and that. And what is the square root of 4? Okay, 4 to the power 1/2 is like the square root of 4, and it is square root of 4 is 2, so that you have 2, you can put the 2 in front, 4 to the power x. And this 4 to the power x, it's still our p here, so that this is p of x. P of x plus 1/2 is 2p of x, like this. 2p of x, like that. And that is the answer. And this becomes the answer. This becomes the answer. Okay, we continue with the next question. So obviously, I mean, therefore, the conclusion is it is true that for this particular question and the exponential function, specific exponential function, p of x plus 1/2 is 2 times p of x, like this. Next point. Next point. Right, so if you look at question 7, it's one more problem that, one more question that we need to solve, and we understand that we have gone beyond time, but obviously we started a little bit after time as well. But we have question 7 to do on what we call the rectangular hyperbola. We have had a fair share of practice on the straight line function. We looked at what you call the straight line graph. Right, we looked at the parabola. We looked at the exponential. Very nice paper. Exponential function. Not only the exponential function, but we looked at both increasing and decreasing. We looked at both increasing and decreasing. We looked at both increasing and decreasing. Okay, now the sketch below represents a graph of f of x equals this. T is the point on f. Here it's t. This is the point on f. What is an increasing exponential function? This one is increasing because the graph is like this. Or when x increases, it increases. And there's this other one, we said that it is like this. I mean, the other way around. Right, so we have the other one that is just this way. So this one is called the decreasing function, 4 to the power minus x. Right, so our sketch below represents this particular one, and t is a point on f. Determine the values of a, p, and q. So in the a and determine the values of a, p, and q, we have the following. Right, so we have a point. Now this one here are the things. So you have x equals 4 here, and you have y equals 2. And obviously this always relates to the q there. So it means that clearly our q equals 2. All right, so the q is the easiest one to quickly get because it relates to y. Now, there's something also about the p, because now at this point, we have that x equals 4. So what you do is you write x equals 4 like that, and then you write x minus 4 equals 0. And now the p is what sits here, and you can see clearly that p itself is positive 4, and we found those, and it remains to find the numerical value of a. Right, so we're going to use f of x, which equals a divided by x minus p plus q. And obviously, this graph passes through t with the coordinates 5 and 3, which is x and y. So y is 3 equals a divided by the x is 5 minus 3 plus the q, and right, so okay, no, I need to change something. Let me first write the following to make it easier to understand. Right, so obviously we've already found the p and the q. Let's just plug them in. So you would have the full that this is x minus 4 and the q is 2. But this is through, okay? It is through the point, this is through the point T with the coordinates 5 together with 3. Right, so it is that sort, which means it's x and y. So that y is 3 here, the x is 5 plus 2, which means that it is 3 equals 5 minus 4, it's 1. You divide here, which means that a, you transpose 3 minus 2, it's a 1. And therefore, you have f of x equals, so you plug in the a, which is 1, over x minus 4 plus 2. Okay, I mean, it means the following. It means that a is 1, p is 4, q is 2. Okay, you've already got the values over there. Okay, so and this was the answer to the first question, 7.1. We move to 7.2 next to solve that one. Okay, this one is called the rectangular hyperbola. Rectangular hyperbola. Write down an equation for h of x if h is the graph of f where a is negative. Write down an equation for h of x if h is the graph of f where a is negative. Let us look at this one, 7.2. To write down an equation for h of x if h is the graph of f where we have that a is negative. So let us continue to tackle this one. And we tackle this one as follows. Right, so we continue. We continue. Okay, there are a couple of things that we have here. And to write down an equation for h of x, if h is the graph of f where a is negative. Okay, let us look at this very carefully. You remember that the graph of f itself is given by 1 over x minus 4 plus 2. Right, if where a is negative, that would mean therefore you have the graph of f of x, but it's at the top and it's negative, so it's minus 1 over x minus 4 plus 2, like this. Okay, let's look at 7.3. Write down the range of f. 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 And to write down the range of f, we proceed as follows. We proceed as follows. So now you need the range of f. Right, so The range of f, obviously, it's just going to remove this one, okay? Obviously, 1 over x minus 4 plus 2 is the graph. And the range, therefore, is going to contain y element of real numbers such that y itself is not 2. Okay, so this becomes the range. This is actually the range there. All right, so obviously we just restricted the part of this one, which is the horizontal asymptote, and we will remove the horizontal asymptote from the thing, from the real numbers. We say y is must not be 2. Okay, the domain, they did not ask us the domain. Let us practice with the domain. So the domain is going to be also all the real numbers such that x is not 4. X is not this one. X is not 4. If the graph of f is reflected in the line y equals minus x, the new graph coincides with the graph of y equals f of x. Determine the value of c. Let's look at that one. Determine the value of c. So now at this point, there are a couple of things that remain very, very important. So at this point in 7.4, we're dealing with a concept called the axis of symmetry. Right, dealing with the axis of symmetry, note that symmetry is what? There are two axes of symmetry that we learn. One axis of symmetry is y equals x minus p plus q. And the other one is y equals minus x minus p plus q. We've already seen that p is 4, q is 2, which means y equals minus 4 plus 2, and y equals minus 4 plus 2. Minus that, and y equals minus x minus 2. Okay. All right, all right, all right, all right. Okay. There's something I need to bring into light here. There are two of them. One has negative gradient and one is positive gradient. Now, this one is minus x plus c. Can call it like that. Or rather, yeah, it's plus x, and this one is minus x plus c because it's running down slope. Okay, I want to bring to attention important things here. I want to bring to attention important things. So each one of these is through this point where x is 4 and y is 2. Okay, so each one is passing through 4 and 2. Y equals this. So if this is P and Q, I want to do it in that form. I want to establish general formulas first. So if these are P and Q, then you'd have that the Y is Q and the Y is Q and the X is P. So that this is Q minus P. Right, it means therefore Y is X, the C is exactly, you can write it like this. Okay, P first, then Q. So for the positive slope line, then you can write this one, which is minus P plus Q. Positive slope is minus P plus Q for the positive slope. Then you also have the negative slope version where you have Y equals minus X plus C. Negative slope version. Right, so the negative slope version is going to be that it passes through PQ. Okay, this is like PQ point where they intersect. Okay, so which means that this is X and Y, and then Y is Q minus P plus this, which means C is P plus Q. The negative slope version of it is going to actually be such that it's going to be Y equals minus X, C is P plus Q. Okay, can use something like this. Right, so I want to come here. So there are two formulas that you can learn. We can use the specific, you can do without them. You can also use the two formulas. This one is Y equals X plus C, positive slope, Y equals minus X plus C, negative slope, and then you get the values of C in each case. All right, now this one here is positive slope is minus P plus Q, negative slope is plus P plus 4 plus 6. Okay, so I wanted to bring that to light. So it is exactly that way. So if you have negative slope, then the negative slope version has minus X plus P plus Q, minus X plus 4 plus 2. So you add to the P and the Q, and then this one is exactly 4 plus 2, which is exactly 6. 4 plus 2 is 6. Okay. Right. And the other one is actually minus X minus 2 there. Right. So now if the graph of F is reflected in the line Y equals minus X plus C, which is this line here with a negative slope, the new graph coincides with the graph of F. Okay, because the new graph coincides with the graph of F, it means that the new graph is the same graph as F. And the new graph coincides with the graph F. It means the new graph is the same as F. And the new graph becomes the same as F under certain conditions. It means that the new graph is F, and the new graph is F means that this one is the line of symmetry and determine the value of C. Right, so for the negative slope, then the C you can get, right, and the C is exactly 6. Right, so you have Y equals minus X plus 6. That is what we've got, which means C is equal to 6. Right, so as I said here, is Y is equal to minus X plus 6. Y is equal to minus X plus 6. But you see, I want to bring to attention things that are very important here. Because another student can come to this and say Y is equal to minus X plus 6 here. And then say this passes through the lines of symmetry that make the new graph to coincide with the original graph. They pass through the point of intersection there. They pass through 4 and 2, and this means that you have X and Y, and this means if Y equals minus X plus C, let's substitute straight away. And if we substitute straight away, it means therefore that this is X and Y, and it means therefore our Y is what? Right, and our X is what? It means therefore our Y is 2, and our X is minus 4 plus C. Okay, you transpose the minus 4 so that C becomes 2 plus 4, 6. That is already the value of 6. You just come here and say C equals 6. All right, so the next discussion is going to be on the mathematics paper 2, and I'm sure that we shall have an exciting time. It was awesome having a discussion on this. Any question there, Tando? Any question that you'd like to ask before we shut down our lesson for today? Any question, any remark, any query? No query. No question, Tando. Thank you so much, Tando. It was awesome having you participating. I'm going to post a video in the next couple of minutes. From us, it was awesome having a discussion with you tonight. Until next time, goodbye. The video is coming on the WhatsApp group. The questions are coming on the WhatsApp group. You can practice with the questions, try the questions, and check the answers on the video. All is well. Thank you, and goodbye to you. Bye. Good night, Tando.